In this video, we are going to talk about behavior of the gases under different parameters such as volume, pressure, temperature, all those things. Alright, look at this particular graph. Here, what you need to understand is that first thing, we are talking about the ideal gas scenario. PV is equal to mu RT. Alright, now look at the y-axis, look at the x-axis. Now what you need to understand here is that remember in the beginning of the last video, we took that at low pressure and high temperature, the gas is going to behave like an ideal gas. Correct? PV is equal to K into T. So that PV is equal to K into T basically tells us that at low pressure, high temperature, the gas, any normal gas you take, they behave like an ideal gas. Look at the graph and you guys can figure it out very easily. This is basically the ideal gas and any other normal gas behavior. Okay, the normal gas will behave like an ideal gas, correct? Now let's look into the next one. Okay, now look at this particular graph. What you have, look at pressure and volume. Guys, as as you start increasing one of the parameters, the other one starts to decrease, correct? Either it's pressure or volume. Look at the graph. More the pressure, lesser the volume. But one thing you have to understand here is that in all the graphs, temperature is kept constant, right? Whatever you're seeing, the T1, T2, T3, they might vary. But then within the graph, the temperature is not varying, isn't it? It's like I have a gas. First, I'm going to take a temperature of, let's say, 1000 Kelvin. At 1000 Kelvin, pressure and volume are inversely proportional, correct? At 2000 Kelvin, pressure is inversely proportional to volume. That means that in that 1000 Kelvin example, I'm not increasing or decreasing the temperature. That is kept constant, isn't it? So if you look at this particular graph, what we can understand is that PV is equal to constant, right? Correct? So PV is equal to constant. Now, if I have to tell this in terms of statement, look at this. Please understand the statement. It's quite easy to understand. What we have? Pressure and volume are inversely proportional to each other provided temperature is constant, correct? That is the meaning of this statement. Now this is Boyle's law. So Boyle's law tells us that pressure and volume are inversely proportional to each other. It's a very, very important law. Please understand this law, okay? It's very important. The next law what we are going to understand, look at this particular graph. Now in this case, what do you have? Volume and temperature, right? See how the graph is going? More the volume, more the temperature, isn't it? So V is proportional to T. Since V is proportional to T, now what do we have? Look at this particular statement. What it tells you is that when pressure is kept constant, not only pressure, mu and P, both of them. When mu and P is kept constant, what do we have? Volume is directly proportional to the temperature of the gas, isn't it? Now this is the Charles law. So these two are Charles and Boyle's law, whatever we just discussed. Okay. Now what we'll do, we'll take this particular one equation we'll take and we'll try to figure out for partial pressures of the gases. Alright. Now what if you have n number of gases with different number of moles? In the sense, look at this, PV is equal to, we'll take mu1 plus mu2 plus mu3 so on and so forth into R into T. Okay. Now what we'll do, we'll separate it and we'll directly write this particular step. So what do you have? P is equal to mu1 RT divided by V plus mu2 RT by V, so on and so forth till n, correct? Now that mu1 RT by V, this is the pressure of that first sample of gas, isn't it? So we have P is equal to P1 plus P2 plus P3, so on and so forth. Now what do we have in this? The total pressure, whatever you have of the gas, of the system or of the sample, it is the sum of the pressures of all the individual gases, correct? Now here there is an equipartition, correct? Here we have partial pressures, correct? Now, this is what we call as Dalton's law of partial pressure. That means what it tells us, the net pressure of the sample is equal to the sum of partial pressures of all the samples which are there in that bigger sample. Okay, so this is Dalton's law of partial pressure. So whatever we have learnt in this video, first is the behavior of ideal gas. This is the graph. Next was Boyle's law, where you have PV is equal to constant, this particular graph. And then you have the third law, which is the Charles law, what we studied. Here V is proportional to T. Look at the graph. And finally, we did the Dalton's law of partial pressure, where P is equal to P1 plus P2 plus P3. Correct? This is how a gas behaves whenever it is subjected unto different parameters like pressure, volume, temperature, whatever. All right. These are the behaviors of gases.